Okay, so hi there, folks. We're now in our next video in college algebra. Here today we're going to talk about this is the continuation, anyways, of the radicals video, and we're going to talk about the laws of radicals right now. Okay, so in this video we're going to present five laws. If it cannot fit, so I will divide this into separate videos, maybe two or three, but let's try to fit it in this sole video. So the laws of radicals are very similar to the laws of exponents since we know that the nth root of a is equal to a raised to 1 over n. So that is, it came from the concept of fractional exponents. So they're very much related, okay, very much related to one another, radicals and exponents, that is. And we're going to have some laws on how to effectively use and manipulate radicals and indices and radicands. So if n is equal to 2a for all a in the integers, that is simply said, I don't know why I did that, but simply said, n is even. Okay, so if n is even, and we will be assuming that a and b, okay, are greater than zero. That is their positive. Other ways of doing this or saying this is that a and b are both in the positive integers. Okay, so let's have law number one first over here. So the law number one, the first law, states that um, if we have an nth root of a raised to n, or it can also be like the nth root of a raised to n. Anyways, the writings is only different, but the way you read it, it's the same. That's why it's somehow the same. They're equal. That's what I said. The nth root of a, the nth root of a raised to n, or the nth root of a raised to n, is equal to a. That is, we cancel up the exponent with our radical. Why is that true though? Because example, if n is a number, so for instance, we have 3 cube root of 2 cubed. Again, recall that this is our identity, that the nth root of a is equal to 1 over n. So since we have this cube root of 2 raised to 3, if we're going to convert this into fraction, this is equal to 2 cubed times 1 over 3. Okay, so 3 times 1/3 is equal to 1. So in essence, we have 2 raised to 3 over 3, which is equal to 2, which is the same with our original number there. So imagine that as a. So therefore, in any number, it is true that this is the answer. Okay, so which means that we need to cancel up the index and the exponent here. So the answer for the first example is 26. Here we need to cancel the 5, the fifth root, and the exponent, which is 5. So the answer here is a minus 5. So this is the answer for the first example, the answer for the second example, a minus 5. Okay, simple as it is, that's our first law of radicals. Let's move on to the second law. We're also going to show the third law here. Overshoot. Let's go back. Okay, so we have now the law number two and law number three. We're going to discuss law number two right now. So law number two states that if we have the nth root of a times b, it can be written that like we're going to separate the fraction or another, sorry, the radical sign into both of the factors. So you can imagine that we can also write this as a times b, though this is a times b, but we're imagining ab here as a single integer. So here we can factor them as two factors, and then we can separate the the radical sign to both of them, bringing the whatever index they have in the original radical. This is similar when we are doing or when we are separating fractions. So recall that in a fraction, I'll just show this as an example. When you have, for instance, 3, okay, 3 over 5, this can be written as 1 plus 2 over 5, right? 1 plus 2 over 5. And this can be written separately as 1 over 5 plus 2 over 5. And that's really legit. If we're going to go from the right going to the left, that's actually addition of fractions of similar fractions. You can check my video about addition of similar fractions in my videos. So that's very similar. The same concept we're doing here. We're separating the radical signs, provided the indices are copied. Let's undo that because we need that space. Okay, let's go to the examples. So just for instance, we are asked to simplify this cube root of 81. So we know that there is no cube root of 81, but we want to get some cube root out of this 81 and then put it outside the radical sign. That is to simplify. Okay, simplification of this cube root of 81. So and then we have here the law number two, also the fourth root of x raised to 4 and y raised to 5. So maybe you can pause the video and answer um, law number two. You can try it by yourself first. Okay, so we need to find a perfect cube for 81 here. So let's write first this again. So what's the perfect cube, which is a factor of 81? Okay, so the perfect cube, which is a factor of 81, is actually 27 times 3. 27 times 3. Okay, because 27 times 3 is 81. Let's check that if you want. So we have 27 times 3. 3 times 2 is 6. 3 times 7 is 21, so that's 81. Right. So let's erase that. So just think that this is 27 times 3. Cube root of, and then we will apply this formula here. That is, we're going to separate them. Cube of 27 times the cube of 3. I am trying to save space here. My goodness, I didn't know that this will be like this. Um, well, the cube root of 27 is 3. Therefore, the answer here is 3. We don't need to 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 uh put a raised dot here. So putting them together is all actually multiplication. So this is our answer, the simplified version of cube root of 81. 3 and cube root of 3. Okay, 3 and cube root of 3. For the for this one, we can simplify this actually by factorization. We'll factor the fourth root. We just need to be ingenious to or tricky. We need some trick in order to cancel up some things. So we're going to factor this as x to the fourth, y to the fourth times fourth root of just y. It's okay. It's really okay to do that because y y raised to 1 times y to the fourth is y to the fifth. So it will give us back to this product. So let's do this. Since they're both y's, actually we can cancel this up by law number one. Applying the law number one here, this will be canceled, and this will leave us with only xy, and then xy fourth root of y times the fourth root of y. We don't need to put the the raised dot anymore. So that's our answer. So it's much simpler than this one. Okay, so that's the end for our law number two. Let's proceed to our law number three. For number three, when we have a radical in which the radicand is a fraction, what we can do, just like similarly in fractions, we can somehow distribute. Okay, distribute. I'm I'm saying this. We can somehow distribute, but not technically distribution. Okay, not technically distribution. We can distribute the radical sign to the numerator and the denominator. Okay. If you do that, so just take note we are copying the indices. It should be the same, and the radicand, the numerator will be that, the denominator will be that. So if we're going to apply this in our example here down below, we will distribute again the fourth root of 7 over here and then the fourth root of 16 over here. Why would we do that? To simplify, because the cube root of 16 is actually 2, since 2 times 2 times 2 times 2 is going to give us 16. This is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So this is 16 is the fourth root of the fourth root of 16 is 2, so therefore we can write that in the numerator it's going to be positive 7, in the denominator it will be um, positive 2. So meaning it's a fourth root of 7 over 2. So that's our answer for number 1. Now for number 2, for law 3, what we can do is distribute them. So when we do that, distribute the radical sign to the numerator and denominator. So what we'll do is take this, the cube root of a plus 2 cubed, and cube root of b minus 4 to the fourth. This is fourth. Okay. What we can do in the numerator is to apply the law number one. We can cancel up since they have the same exponent and radical. So we are done with the numerator, which is a plus 2. Here in the denominator, we can convert this into fraction by our definition of a radical. So we will say that b minus 4 is equal to 4 over 3 raised to 4 over 3. Okay, raised to 4 over 3. Okay, then after that we can see that 4 over 3 can be rewritten as um, b minus 4 raised to 3 over 3 times b minus 4 raised to 1 over 3. Okay, if we're going to do that, the 3 over 3 here will become 1. So this will become 1, cancel up. So meaning this is going to become just b minus 4. And then the other one over here, will become b minus 4 cube root of b minus 4, the cube root of b minus 4. Okay, so our denominator will be quite somehow complicated. It will become um, what do you call that? B minus 4 times, I'll just put this below, times the cube root of b minus 4. This is quite um, that there's a lot of space. My goodness. Um, let me write this again. So b minus 4. So we can do it like we can write this as a plus 2 all over b minus 4 all over or times the cube root of b minus 4. Okay, so that's quite complicated, but the other way of looking this denominator is that again we have cube root of b minus 4 raised to 4. Maybe we can apply rule number 2 with this. Doing so will give us, in rule number 2, it will give us something like this. Cube root of b minus 4, okay, raised to 3 times b minus 4. So another method. So what we can do is again apply the rule number 2 for this. So what we have is cube root of b minus 4 quantity cubed, which we will apply the rule number 1 in a while, and then cube root of b minus 4. Okay, so here, apply the law number 1. This will be cancelled. What we have is b minus 4 times the quantity of cube root of b minus 4, which is exactly the same with our answer in a different using a different method. So that's what is great in mathematics. Whatever you do, you will end up in the same method. Okay, in the same final answer, even though using the same method, using different methods. I mean. Okay, so let's go back in law number 3, and then that's law number 2 and number 3. Okay, you can take a snapshot if you want. Okay, and let's proceed to law number 4 and law number 5. These are our last parts of our laws. Okay, so for law number 4, it is just stating there that if we have the nth root of a raised to m, we can just put the m outside. I somehow introduced this in law number 1, but why not? Okay, so if we're going to do this in law number 4, that as in using the index first, using the rooting first, and then the exponentiation, you may think which one is better. Okay, so it depends on your familiarity of the numbers. Say for instance, in this setting, you will tend to do by PEMDAS. You will tend to do the 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 exponentiation for first. So that is, you're going to raise this to 4, and then get the fifth root of that. So that's quite tasky because raising this number to 4 will be very big. So what we can do is reverse or give some trick, okay, by law number 4, in such a way that we're going to do the rooting first. Okay, the rooting first. That is, we can rewrite this as in the fifth root of 32 rather, raised to 4. Now we can see that we need to get the rooting first. And the fifth root of 32 actually is 2. It's 2. So 2 times 2 times 2 times 2 times 2 is going to give us 32. Okay, and so therefore this is 2 this time raised to 4. And 2 raised to 4 is quite a happy number because 2 times 2 times 2 times 2 is just 16. And it's quite doable compared to, you know, you you get you exponentiate first 32 by 4, you raise that by 4 and then get the cube root of that. So that's quite tasky to do. Okay, so again, you just need some familiarity of numbers in order to make this a successful one. Here, let's do this. Squaring 64 is quite a big number, but if you know that the cube root of 64 is 4, so that will make things easier for you. So get the exponent out. We know that the cube root of 64 is 4 because 4 times 4 times 4 is 64, and then we just need to square that 4. That's going to give us 16, which saves us a lot of jobs, a lot of work to do. Okay, so that's law number 4. For the law number 5, um, this is it. The mth root of the nth root of a is equal to the m times nth root of a. Okay, so if we have an index and the radicand of this index is another radical, again the radicand of this radical is another radical. So what we can do is provided they're on the same base, is to multiply the indices and make them under one house, okay, one roof, one radical sign, shall we say. So for instance, here we have the square root of the cube root of 9, the square root of the cube root of 9. So um we can, what we can do here, again, imagine that there is a 2 here. Okay, there is a 2 there. So therefore, the square root of the cube root of 9 is equivalent of saying we multiply first 2 times 3, that's going to give us 6, and then the sixth root of 9. That's our answer for the first example for law number 5. For the second example, for the law number 5, we have the fourth root of the cube root of 12. So we need to multiply 4 times 3. It's going to give us 12, and that's going to be the 12th root of 12. Okay, the 12th root of 12. Okay, so that's it for this video. Quite a long video, but at least I have provided you with 5 laws of radicals. So again, reviewing the 5 laws, we have the first law over here. Maybe you can take a snapshot if you want. Take a screenshot of it. The first 3 laws. Law number 1, the nth root of a raised to n is equal to the nth root of a raised to n, which is equal to just a. Law number 2 is the nth root of a times b is equal to the nth root of a times the nth root of b, which is also equal to the nth root of a times b as factored. Law number 3 is the nth root of a over b, which is equal to the nth root of a all over to the nth root of b. Law number 4 will tell you that the nth root of the nth root of a raised to m is equal to the nth root of a all raised to m. And law number 5 will tell you that the mth root of the nth root of a is equal to the m times nth root of a. And that's it for this video. Thank you very much for watching, and yeah, why not hit the like button and subscribe. Thank you very much.